Hello and welcome to another episode of Antimatter Skunkworks. Before I begin today, I want to cover some business, though it's not advertising. In fact, it's kind of the opposite. In a nutshell, YouTube has once again changed its policies, and they've decided that they want to monetize all channels, including little teeny tiny ones like my own. You don't have to know what all that is. I actually don't know what all of that is. In a nutshell, you can monetize a channel once you get 1,000 subscribers. So I'm only 996 away. 994 away. Hey, just gained 2. And it means that they'll add more commercials to your channel, and you receive revenue for how many views you receive and how many minutes, and they keep changing how you get paid. So I don't get anything, and now that they're changing the policy, I still won't get anything, but you're going to have to watch more commercials. I don't like commercials, and I wouldn't monetize my channel even if I could, so I'm going to fight back in the only way I know how. Until they crush me like a grape, I'm going to tell you about basically ad block. Honestly, what you should do is go in and Google how do you eliminate ads on YouTube. It may be a little bit different for whatever browser you use. Maybe you shouldn't Google. I should have said you look at the internet, because Google is the biggest offender. Google owns YouTube, and they also own Chrome. So I know a lot of you know this stuff, and I get it. So, but if you don't, and if it helps anybody, I hope it does. So consequently, last time I went into Chrome and looked for an extension that could block ads, they weren't there because Google doesn't want you to have them. It's why I really don't use Chrome. Got the squirrels active this morning. Anyway, I use a browser called Brave, and it works in Brave, but I'm pretty sure it also works in Mozilla. It's called AdBlock, and you go up into your extensions or add-ons or whatever they're called in your browser, and you look for some kind of ad blocker. Just install them all. Just look for them, install them all. And for me, it really is just transformative. I go on YouTube and I watch a video, and when I'm done, I watch another video, and I'm done, I watch another video, and I never see that whole little, oh, you can skip this in 5 seconds, or your video will start in 30 seconds. I don't even see that at all. Now, I know that they like to ruin things. Humans like to ruin things, and this won't last forever, but I've been doing this for a good 5 years now. And the day that it doesn't work anymore is probably the day I'll stop making videos and stop watching videos, because that's why I left TV. I don't want to see any commercials. So if you didn't know this, go try this, and it will make a big difference to your YouTube viewing experience, and you're welcome. All right, so now, getting on to today's topic, Nixie tubes. You know what they are, otherwise you wouldn't be here, and if you don't, you probably know just from having looked at the picture. This Nixie tube clock was made for a friend, and I've done this over a couple months ago. It's been sitting on my entertainment center for a couple of months, as I just wanted to make sure it was, properly working and didn't break. Also, I was kind of enjoying it because I think they are awesome on many different levels. So anyway, I made this clock for a buddy of mine, and he's kind of I want to say he's a simple guy. He's simple. His tastes are simple, right? His car needs to go from A to B, and the walls in his house, white's just fine. So he and I both watched this show called Travelers, and it's a really good show on Netflix. I think it's a really good show, and in fact, I wanted to see what clock they showed on that show. This is where he heard about him. I had seen him before, and I often thought I might do something like that. But it was the first time he'd ever seen it, and it's one of the few things he's ever expressed a lot of interest in that I'm pretty sure he didn't buy for himself. I've actually given it to him. It's Christmas now, and that was a Christmas present, so I know he didn't have one. Anyway, I went back to Netflix Travelers and looked at the clock that was in that show, and it was boring. It was literally just a block with beveled edges on it. And I actually thought, because it was kind of, not real in focus in the show, that it was maybe wood with painted gray or something like that. And I found that clock actually on the internet, and it's $600, and that's a solid block of aluminum. And I decided I wasn't going to do that. but I could come up with something else that was simple but looked really cool and got the job done and wasn't $600. And so that's what this story is about. So sit back, fasten your seatbelts, enjoy the ride. Let me know in the comments, did you like it? You want me to change things up? Would you like to see another one? All that stuff. To cut costs, what I did was I ordered this kit, which you assemble yourself in order to power the clock, and then I scoured the eBay for some inexpensive Nixie tubes, which come from Russia. In one case, I think I bought them from the Ukraine, and they come from Latvia. So when you do this, you have to, allow for like 3 months worth of travel time, so that it's not a fast way to do this, but you can find some good prices if you look around. To make sure I had everything, I went ahead and measured each one of them and recorded where they went, like R29, R30. That way I can easily go and pull off the R value or Q value or C value or whatever I need in the schematic, but also to make sure I had everything there. This was tedious and not a lot of fun. So this is the first part of the circuit. You built a low voltage circuit, and so far I'm pretty happy with the quality of my solder joints and how easily this is going and how good it looks. But finding where the components go is a little bit like Where's Waldo? I'm doing the next part, which is this LED here, and if you look over here, I have a Rev4 board, and I've got the Rev4 manual, and it shows the LED here between the crystal and these 4 pins. And there's the crystal and the 4 pins, but no LED. So the search begins. There have been very few problems with the board so far, but they stressed very strongly in there that if you don't get R1 and R2 the right way around, you'll put 170 volts on the microprocessor and blow it up. But then on the board here, they don't mark R1. So I think that's kind of funny because I looked all over for it and couldn't find it anywhere. R2's marked, and I assumed it would be right next to it. And when I looked in their picture, they are, so I'm going to assume that's R1 and populate it. If I blow something up, I blow something up. I've now done basically step 2. I've created the low voltage power portion and the high voltage power portion. And each time you do, you get to a point here where you stop and you do a check. So I checked to make sure I powered it up, and I don't have a plug yet to go in here, like a wall wart or anything. So I went in and soldered on 2 wires and used a power supply I have at home. And I turned it on, the light came on, I checked the voltages, it was 4.96 volts, it's a 5 volt regulator, so that seems right. And everything seemed okay, nothing smoked. So I went on to the second section. When I got done, you're supposed to turn on, and then you can test across here. These two will give you the 170 volt power output. And you have to be careful, of course, at that point. It's pretty high voltage. You don't want to shock yourself, right? But I did that, and I got 180, which is good. It said it should be over 170. So I got 180, so I think I'm good to this point, and I can move on to the next step, which is apparently the backlight LEDs. When my Nixie tubes arrived, the box came completely soaked, like it was thrown into a swimming pool, all the way to the inside. This is actually a day later, and it's still wet in there. It was very well packaged, as far as shock goes, but I guess they didn't expect the shipper to throw it in a swimming pool for a few days. And you can see that there was a lot of tape around the outside, and that's the only thing that held it together, because you can actually see, this is a cardboard box, and it's really just like fabric underneath that tape. So I was concerned about the Nixie tubes and how, if it affected them, and let me show you that. So I almost rejected the package, then I realized that these tubes are probably vacuum sealed, so everything's well protected except the terminals, and they are used and have solder on them. Plus, I think corrosion is the kind of thing that happens over a long period of time, so I figured even though they were kind of moist when I got them out, I figured they were probably okay. One problem, however, is these terminals are very short, and they're shorter than the height of the LED over which they go, so they won't reach the board. And I'm going to have to figure out a way to extend them. But when I told the maker of the board this, he gave me some suggestions on how to solve that, and he said you could hold these up to a plasma globe, and if they glow, they're okay. And strangely, I happen to have a plasma globe, so let's see that. So So I got this plasma globe from a friend, and as you can see, it's not doing so well. It doesn't even go to the outside glass anymore, unless you put your hands on it, and then it seems to work okay. So let's see what happens. Pretty cool. I guess this one works. To solve my height problem, I'd like to think I'm making some lemonade out of these lemons. I put it on these stalks, which kills two birds with one stone, right? It gets me up above the LED, which now may be too low, we'll find out. But it also creates some space between the tops of these things and the bottom of the Nixie tube so that I can put this inside a case. I think it was originally designed just to be seen raw like this, but I wanted it in a case and it wouldn't really quite fit with these tall components here. So we'll see how this works. Doing it, however, is a bit of a pain. I have this header, and I'm taking pins off of it individually like this, and then I stick it into these holes like this, and 13 of them for each one, and solder them into place, and then I have to stick the tubes, which I've cut, to the right length, but it also smashes the end. I'm pretty sure the camera is not going to pick this up, but I will move it around there a little bit and see. And what I have to do to make it round again is I take a pair of pliers and I have to squish it back into shape, and then I force this sacrificial one through it to open up the hole so that I can then put this on the pin. Okay, I hope that this is focused. My camera's been giving me problems. I do have a new one on its way. Unfortunately, it's a bit of a step down, but I don't make any money on these videos, so I need to keep my budget a little bit low. Anyway, if it's not, then I will try and reshoot this, I guess, so you probably won't even hear this in editing. So I thought about remote mounting, kind of like this, the Nixie tubes, but I tried several different ideas, and this is what I've opted to do. But when I put it on, the Nixie tube can be, well, you can see that these are actually quite crooked to begin with. They can flex a little bit, but that also means that the Nixie tube, when it goes on, it can be pushed that way. This one's not soldered on, so it can go on like this or like this all around the place, and I was afraid they would all kind of wind up like crooked teeth. So I decided to make an alignment tool. I'm just going to have 6 holes in it. They'll be hopefully the right diameter for this tube to fit into. And I'll put that on top, and then I'll solder them all in. And that's the plan. So let's just hope it actually works. Now you may be wondering, this breakout board is the same. I'm doing this for the same exact reason. These components were too tall for the top, so I decided to relocate them. Plus, the power connector is here, and I didn't think it made sense with this board being up toward the top of the finished unit to have the power connector so high up. Usually they're sort of in the bottom, right? So this allows me to relocate this down at the bottom, so when it's plugged into the wall, it won't be, so visible. So victory, you can see the Nixie tube goes all the way through the hole. This one's a little on the tight side, but that's okay. I'd say this one's just about perfect. The first hole is a little bit loose. Let's see if I can demonstrate. Yeah, it slides through very easily. But it's still okay. I mean, it'll still, limit the amount it can be off. And visually, I think they'll all be straight if I use this tool. Okay, so all of the stalks here are finally done. Ignore the fact that they're different lengths and they're all a little bit crooked. None of that theoretically will be seen, but now comes the hard part, trying to line all that stuff up and get it in there. It's going to take forever. It took forever to get the first one on. I got 5 to go. Alright, so none of these Nixie tubes are soldered, but you can see they're all working. 1, 0, 1. So I missed the 2. 6, 7, 8, 9, 0, 1. So the 2, I saw them all working before. I'm going to move them. See, this one went out. 2s. So yeah. Anyway, I had them all working at once. That tells me they're all good, and if I solder them on, I don't have any issues, and I don't have to correct anything. So he says to put them on, or the instructions say to put them on, one at a time, because if there's a problem in this one, it could lie anywhere because they share lines, and so you need to do them one at a time, and if you encounter a problem, fix the problem. I didn't have that opportunity because my fixture wouldn't go on. I couldn't solder them on straight without my fixture. and the fixture kind of only works if they're all there, so I decided to do it this way. So fortunately they're all working, and I can just solder them on now. And let me tell you, putting one of these on is a nightmare. It's like, I want to say is easily 10 minutes per, and on a couple of them I was off by one, I was clocked by one, and so I had to pull it off and do it all over again. So easily, I would say an hour and a half to 2 hours just to put these 6 Nixie tubes on their little stalks. It might be easier on a board, probably is easier on a board, but this is what I have, and I don't know, I think it'll work now that I've got it together. I'll just go solder everything up, trim the backside, ones that are kind of too long, and it should be fine. Here's the status. This is my brand new camera, by the way. It's the first time I've ever used it, so I hope it comes out okay. As you can see, I got a missing tooth here. And what happened is it was working fine. Well, hang on, let me turn this off. I put in these two guys, and suddenly this one was brighter than all the others. I didn't know what happened, so I wound up taking these two back off, and it was still brighter than the others. I put them back on. Those probably weren't the cause. The only tool I seem to have in my chest is to try and reflow the solder on these joints here. And that wasn't really working. And what happened was during the process, I had it on its side and it fell over, and when I picked it back up, it was normal. That should have been my first clue, right? Nothing happened between them all working perfectly and this one going out. The only thing that I did was I moved it into this box, and I did it this way. I kind of dropped it like that. And I can even kind of hear almost like something rattling, which is annoying. I don't know if that's normal or what, but anyway, I was trying to, that's all I did one time, and I think that should be well within the tolerance of this thing to take, a hit. I can't build this thing and then have it fail on the way to my friend's house or something. So I believe that these things are way too sensitive this way, and the reason is I'm satisfied with the soldering on the board down here, but the soldering up here I'm not happy with, and the reason is that these tubes are brass, and while you can solder to brass, I've done it many times, to get a good joint, I mean, there's a lot more mass in the brass, and it has a different, the solder's going to melt at a different temperature there. You're going to need more heat. I think I also really need, in order to get it to flow properly, I need to get the soldering iron on both the terminal of the Nixie tube and the brass tube, and then you should actually see it suck in. And I'm not seeing that. In fact, on the tallest of these, since they're not the same height, there is really very little room. I can't even get my soldering iron on there. So I think I'm getting cold solder joints, and this is just unacceptable. So I've got two ideas for fixing it. First one is, and I hate to say this because it was so hard to get them to this condition, and I like the overall style of this, I think I'm going to have to cut these off. That way I can desolder them one tube at a time. If you try and desolder the whole thing, you heat up one, by the time you go to the other one, this one's cooled and it's still, and you have to work it off. You wind up overheating everything so much. But if I cut them off, I can just put the heat on here, pull the tube off. And if I cut them all off, I'd like to see how many of them just slide off, how many of them don't really have good contact at all, maybe no contact at all. So we'll see. But then I think I could maybe put the tube back on one at a time and solder them on this end, because the other end is a lot more tolerant to heat, and so I can get a better connection down there. If I heat up too much here, I'm afraid I'm going to damage the Nixie tubes. Right now I have reason to believe they all work fine, so that's plan A, or I guess technically maybe plan B or C. I don't know what I'm on right now. And here they are, completed. They're not perfect. There's a slight size difference, and this one's got a little mark, but I wanted to quit while I was ahead because I was pretty sure I was going to mess them up. So here's my latest setback. It's this piece that I worked so hard on. Crumbled when I tried to drill that hole in it. I'm going to try and glue it, but I don't have a lot of hope. Looks like this one actually tore up a piece too. Lovely.
Before hazardous conditions begin. Urgently complete efforts to protect life and property. Have food, water, cash, fuel, and medications for 3+.
Alright, this is the first pass on thick aluminum, and I'm really happy with it. I'm going to try and get as close as I can, and hopefully it's focusing. You can see it's not super great quality, the finish isn't so great, but that's okay because this is an old bit. It's running in conventional mode instead of climb. It's a conventional cut versus a climb cut, which doesn't give you as good of quality of cut, and I think that it's okay because I just need to remove a lot of material. And what I'll do is, to get the finish that I want later, is the last pass I'll switch out the bit with a new carbide bit. This is a high-speed steel bit. I'll switch out with a new carbide bit and do a pass in the other direction using the climb cut, and hopefully that will give me a much better finish in the end. Alright, there's the first part. The pocket is done. That's actually part of the design. Come over here. And the finish is even better. Of course, I think a new bit helps, but also I think it just ran over the outside so many times. You know, on the deepest one, it's kind of doing the shallow one as well, right? And I think it just kept cleaning it up as it went. As you can see, it didn't cut all the way through, which is a bit of an annoyance, but I can take care of that afterward. In fact, I saw a guy, when it was this thin, he was able to do it with just a, yeah, I can feel it's almost like foil. He was able to do it with just a, like a carpet knife. Well, there's the remnants of another snapped bit. I don't know why it did this so perfectly, and it can't seem to get through this. Exact same settings, brand new bit, everything's the same. I thought because my pocket had this little wall in between, so it was digging through aluminum on both sides and had too much resistance, so I shrank the pocket down so it would cover up that, and now it's still broke, like right away, in fact, faster than the other one over here somewhere. So I'm going to slow the feed rate down and see if that works. Yeah. Well, it made it. About halfway through I slowed the bit down even a little bit more, but it seemed to go okay. You can see the finish isn't perfect, but I've got another finishing pass that goes the other direction. It should be a piece of cake. Oh man, why do I say that at a time? Never say it till it's over. That's because it's already cut out, so it's just going to go around and finish basically that. And it took 52 minutes. Everything's hot. I wasn't sure if the vacuum was going to make it because it's generating so much heat down in here. I had the doors open, and whew, that's probably the roughest I'll ever be on the machine though, because the plans I have are basically 1/4 inch aluminum. This is 1/2 inch, so yeah. Well, 3 bits and the better part of a day later, and I finally have a part. You can see the finish. It's not too bad. Nothing that some sandpaper or maybe a file can't clean up. Maybe sandblasting, give it a frosted look. I'll have to decide. It's only the outside. I put alignment holes for the through holes, and I'll just drill those with a drill press. And then I need to cut out the inside. I only cut out the front face where the button goes because I wanted that to be thin and flat so that the button wouldn't sit crooked or something. Also, I didn't want to have to cut through so much material. But the rest of this really doesn't matter how pretty it is. And I didn't see any reason to spend more and more hours breaking bits and running a machine, generating all this heat stuff when I could just do this another way. Not sure what that other way is, to be honest, but I'll figure it out. And there's the finished part. It only took me another day to cut it out with a jigsaw. The progress was really, really slow. Plus I drilled holes in the corners to, so I can get the blade in. And then I had to drill out these edges here to accommodate the metal inserts on the wood that goes above it. But, you don't see any of this stuff. It's all on the inside, so all you see is this front face here.
And there are some tool marks I'm not super happy about, but I took some sandpaper and it got a little better through the middle, but I can't seem to get, these ears are really hard, they're round, and it's hard to get the same kind of action going. I have a wire wheel, and I tried to use that, but I didn't like the way it looked on a test piece, so I didn't use it on this. Yeah, a lot of work just for one little piece. So you can see it's starting to shape up now. This is more or less what it'll look like, except the top will be the same color as the bottom. This little messed up spot here really is where the switch goes. It was marking where the switch goes. The only thing I don't like is it's sort of taller than I wanted. I actually preferred it more like that. But there's just no room. There's not enough room inside to put the switch. The little board I broke out for power, which was too tall to fit up in this top section, and the board with the Nixie tubes on it. So, but I might be able to pull some of it out. I don't know, it's starting to grow on me a little bit, I guess, this way. Kind of getting used to it. Alright, so I cut out some clearances for the switch, and now for the power board. I'm using a combination of a Dremel tool and a chisel. I think a chisel will be best for all of it, but I'm afraid that the chisel will break this. It's pretty fragile, you know, the wood splinters easily. So I'm getting very close to being finished now. I drilled out the back so that this nut could be recessed, and an all thread goes through into the part at the top, and then the nut basically ties it all together. Then all I have to do is screw the feet on, and however high I want to go, can adjust it. And then I have this cork that I can put on the bottom so it doesn't scratch anything. And I drilled a little hole for the light sensor. And then somewhere in my pile I found a connector that goes on here. This is an S-video cable, and it has 3 wires consecutively, which is what I need to connect to this post down here to provide signal to the switch and to the LDR. Alright, I've run into a host of little problems that have been an annoyance. A few times trying to put the RealTime Clock module in. You can see it's wrapped in tape here to keep it from shorting on anything. I had it pressed down on the board and everything bowed in when I was assembling it, and a couple of things stopped working. I had to go back in, reflow the solder. I've got it all working now again. But also when I put it together, you could see light coming in between these two pieces even after it was bolted down. And I think even though everything's been machined and is pretty flat, it's only really held on the end, so there's nothing in the middle to sort of clamp it down, and it gives it a little bit of a bow, and it's a little distracting. So I think I'm going to use a little bit more of this cloth tape on the inside, and so as not to sandwich it, I think I'm going to put it vertically just to basically block the light. So I'm going to run around the whole inside of that. Now, also assembling the thing has been difficult. In order to solve my RealTime Clock problem, I have to leave it loose, and I stick it out through the top, I assemble the whole thing, and then I push it back down. No place that I've mounted it has been good enough. It needs to come up in here, but at the same time, if I mount it, then you kind of can't get the battery out. So if I just leave it loose, but I wrap it in this so it doesn't short on anything, then the grill can be taken off the top here, and it can be pulled out, battery can be changed, put back in, and that way we don't have to disassemble the whole clock. Those are all the trials I've had, but I've also had problems with, as you can see, the finish has some kind of runs in it, and due to the poor quality of the wood, you can see the grains, and these things don't really make me happy. The reason I chose this wood is because I was having a difficult time finding wood that was of a higher quality but thick enough to make a box out of in one piece. In retrospect, maybe I should have done a bunch of layers and then just stacked them up and glued them together or something to get a better finish. But I think I don't think it's that noticeable inside. You really notice it when the light shines off of it, and I don't know. I think it'll still be okay. Now that I'm completely done, I was going to set the time feature, but that's when I found my next problem. The real-time clock circuit that I have inside has a temperature sensor on it, which means I probably shouldn't have wrapped it in cloth electrical tape. So this part comes back off and that comes back out, and I gotta figure something else out. That cloth electrical tape on the top of the board where this might short out, and I'm just going to go by hope. Although I did remove the terminals on the end of this thing, so that those are the things I think are most likely to short out. And there it is, in all of its glory.